All right, border problems. These are the other type. Okay, so we have this fixed outside border, sorry, outside kind of frame rectangle, and then there's going to be a kind of a border that kind of encroaches in from them. So the photograph is inside here. This is the part, just so you know what they mean here. This is the part that's 8.5 by 11. This is what they use in the States instead of A4. It's very popular. And then the distance between here and here, if you could draw that at right angles, that's X, and it's the same as if you had drawn it here. So it's like a fixed width, even border all the way around the thing. So complete the diagram on page 7 and express the area of the photograph. So this area in here, express that as a function of everything else. Okay, so this length from here to here is going to be the 11. It was originally, sorry, 8.5. But now it's been reduced actually by 2x. It's been reduced by x on both sides. And this kind of distance from here to here started out as 11, but then I also had to take off 2x. So this area is actually just going to equal those two dimensions, 8.5 minus 2x times 11 minus 2x. And let's go ahead and graph that. So I'll make a new page, make a new graph, and we'll just graph it as I said. And you can just type this in like this, 8.5 minus 2x times 11 minus 2x. And I'll probably get a horrible parabola. Oh, actually, that's not bad. Let's go menu zoom box right now. And just make it, well, I kind of want to see the 0, 0, but then let's just kind of go to there. Like, that's not going to be much different. Okay, so is that helpful? Is that surprising? Like, what's going on there? Let me cheat and grab that and copy paste it. Okay, copy paste it in here. Let's see what this kind of stands for, because this is probably kind of unexpected to you. What's really happening? Actually, this will look better if I can show it to you on here. Like these values of x. You know what? We could talk about this easier if I traced it. So, oh, it zoomed in. That's weird. I didn't want it to zoom in. Why did it zoom in? Okay, so if that width is something like 3, or you know what? Oh, if you zoom, notice how I'm tracing backwards. I'm tracing to the left. It'll show me more window to keep my tracer on the line. Okay, so if the border is 1 inch, let's go all the way back to 1 inch. Then the area is actually quite large. The area is going to be 58 something square inches. As that area gets bigger, oh, let me just zoom out. Maybe that'll work. Zoom quadrant 1 or something. Yeah, and then as I move my tracer, menu 5. Yeah, okay, this is better because I can see everything. As that area gets bigger, as that border gets bigger and bigger, as you imagine, as that border gets bigger and bigger on that paper, the area left for the photograph starts to get smaller and smaller until a certain point where if that border is all the way up, can you guess? If that border is, notice it snaps to 0. 4 1/4. Now 4 1/4 shouldn't be a huge surprise because that's exactly what's going to make this 0. 4 1/4 makes that 0. At 4 1/4, there's no area. That border is entirely filling the whole paper, and the photograph has been squeezed down to a sliver and actually down to nothing. Algebraically, this function lets me go farther. It doesn't make any sense because now the border is kind of like the left and right border have now overlapped each other if I make it bigger than 4 1/4. So I've got this kind of overlapped negative area for the photograph. At some point, they overlap so bad at 4.875 for some reason. They're overlapping, like all 4 borders start to overlap, I think, and that negative area starts to become positive area, and it makes absolutely no sense. You can't have a border of 6.3 when the whole width of your paper is bounded by the fact that if it goes beyond 4 1/4, I can't see the photograph anymore. So really, all of this stuff beyond this first, get right back to it there. Beyond this, anything larger for x makes absolutely no sense. However, algebra doesn't care. Algebra is going to let me do whatever kind of crazy things I want to, or it wants to. It doesn't know what's going on with this picture here. So the practical domain really does stop here at the coordinates here. I probably want to see more of this this graph up this direction though. So let me actually just go in here and let me change this window setting. I think I want to see a higher y max. I want to see a y max of, is it y max that I want? Actually, if I worry about, yeah, let's just try that. Let's, yeah, what is that area if I don't use any border at all? It's probably pretty large. Let's make it, it's probably bigger than this, yeah. Let's make it even bigger. Can I estimate 8.5 times 11 in my head if x is 0? Is it even that big? Yeah, it's almost 100. Make this a little bigger and let's move it down a little more. Just so I can kind of see that. I think I want to know where that is. Let's go 140, I don't know. Yeah, okay. So now this looks a little bit better. And it doesn't look quite as crazy in terms of when the thing disappears. It does dip below the, I'm trying to move this different. It does dip below the axis, but it's not quite so horrible anymore. Like, can I move this label, please? Okay, I can't. But, you know, so all this area in here, all these values of x make sense after the border could be 0, and then I'd have the kind of the maximum possible area of the photograph would be the entire paper. Then as that border gets wider, I get less and less and less and less area until it hits 0. And then nothing else makes sense. So, yeah, in fact, this would also be smart. Let me just do this. I should also end the x maximum like after that point pretty soon. It's like this really is all I care about if it ends about there. Just this little segment of the graph. So let me re-copy paste that into the graph a little bit better, or onto that page. Yeah, so I actually like that window a little bit better. Okay, let's go back to here and see what it asked me for next. Okay. It's saying, solve the following questions algebraically or graphically. If the border was 3 inches, what's the area of the photograph? Okay, that's easy to do on the calculator. You can either go trace and just type 3. I learned that this year. 3, 12 and a half, I like that. Or you can go to a calculator page and plug it in for f of 3 of x. F3 of x. So that point's kind of down there. If the border is 3 inches, what's the area? 12 and a half. It says algebraically or graphically. I kind of did graphically. The editor wants the photograph to have an area of 56. So basically I want the y here to be 56. So what's the x that has to go in that coordinate? One way to do that on the calculator, which is kind of nice, is graph another function. Whoops, hit tab. If I hit tab, I get this back again. And I just do a y value of like a horizontal line of 56, and I try to see where that intersection is. Let's get this out of the way. And so I just go menu, analyze, intersection, and I give it a window from left of it to right of it, and it snaps to it. And it's 1.082 and 56 exactly. So 1.082 is my answer for that one. And we can be pretty sure that that's rounded to exactly 3 decimals. Again, to do this algebraically, be my guest. You can plug them into this equation, and you can find all that stuff that way. But we have the fancy calculator. This would be on the calculator section, so I'd go ahead and do that. This is the same thing, but now the fixed part of this, so there's this garden that's fixed that's in the middle here, and we're going to expand outside of that with a fixed width border. So here, the 16 and the 12 is what's already here kind of on the inside. And then the 12 is built on the outside of that. So you have to read these problems carefully for this context, and you got to figure out which kind of thing it is. Is it that the outside's fixed and we're kind of got an inside encroaching border, or is it the kind of this inner area is fixed and we're building a border kind of around that? So there's the garden and the walk, and then let's do the area. The area would be, oh yeah, so I need this full dimension and I need this full dimension. Well, this would just be 12 plus 2x. You getting used to this? And this would be 16 plus 2x. So the whole entire area is 12 plus 2x. And notice this is not in any kind of vertex or whatever form. It just says write an equation, so you're fine there. Solve the following equation the way you want. If the walk had a width of 4 feet, how many square feet? You know what? I did the last one completely on the graph, so let's do it this way. So this would be 12 plus 2 times 4 and 16 plus 2 times 4. Can I do this in my head? Those are kind of big numbers. But you just plug them in and that's what you do. Yes, I cheated at the last part, so you know, there's that. If the gardener had only 350 square feet to use, in other words, like the concrete that he could pour, if there was a limitation to how big this total outside border could be, that's kind of a strange way to think about it, but sometimes that's the way it happens. What should the x be? So the a is limited to 350. So we're basically trying to solve this. If 350 has to equal 12 plus 2x times 16 plus 2x, how do we solve that? This is probably best solved by expanding and doing quadratic formula stuff, because I don't know, or factoring, because I don't know what's going to happen. Let me try it. All right, I'm doing some major cheating here, but I know you know how to do this. So I did some expanding and I did some solving. I went all the way to the point where I said, okay, that equals 0. So if 0 equals that thing, then the next thing I would do is probably factor this out by a factor of 4. So this is going to be x squared. See, I'm good for some stuff. That's 14, I think, minus, oh my god. And you can see my secrets here. Now I need to take 158 divided by 4. Does that work out nicely? Oh, no, it doesn't. Oh, shoot. Let's try something else. Factor out. Yeah, it doesn't really help. I think it's quadratic formula time, actually. All right, so by quadratic formula, I get that. Of course, those are coming out as decimals a lot quicker on the graphing on the calculator. So again, be my guest. That'll work either way. This is definitely a calculator section of the thing. And that's it. So I will see you in class. Next day's review day and then test. Actually, since I have a minute, I probably should have finished this a little bit better for you. These two answers are the things that come up in the algebra. And the algebra can be kind of a mess, right? Because some of these parabolas are going into negative domains. It makes no sense. If I solve this and I look at what these answers are and I look at them, actually what the numbers turn out to be, one of them is going to probably be ridiculous. And if I change these into decimals, and you would see this on the graph, yeah, this is ridiculous, but x could be positive 2.4. That makes sense in this situation. I could build out 2.4, and that would be limited. The other one's kind of like that one with the picture on the yearbook, where the x is some weird negative direction. It goes the other way, and it somehow overlaps negatively and gives us a positive area. It makes no sense in real life, but it makes sense somehow in the algebra. Anyway, so actually the only answer I really want here for the width of that thing is this answer here, this 2.4 number. Okay, now that's it. I'll stop. Thanks. Bye.